All right, example 18, not just any old example 18, this is the important example 18. So I'm going to show you the connections of what we did before to what we're doing now. All right, so before, for this problem, we would have taken the antiderivative, and we wouldn't forget our plus c, and then we would plug in this value, 0 minus 0 plus c, so 5 is c, so we would get our function f of x equals 2/3 x cubed minus 2x plus 5. And then to find f of 2, we would go ahead and take 2 and plug it in. All right, so this would be 16/3 plus 1, so 19/3. So there we go. That's the old way. Now, there's a problem with this because it requires us to know f of 0 equals 5. It requires us to find the antiderivative and then plugging it in. So there's another way that we could do it by using a definite integral. So if we want to find f of 2, we could show that we could start at f of 0, right, whatever the value is there, and then add what we accumulate from 0 to 2, okay, of 2x squared minus 2 dx. All right, so in this case, f of 0 equals 5, which we needed for before. This one, antiderivative here, or we could just use a calculator, right, to save some time. So if this is a function you can't find the antiderivative of, then you're going to have a hard time doing it the first way. But this one is easy enough, okay? It's going to be the same kind of steps as before. And we're going to evaluate from 0 to 2. So we get 5 plus, and this would be 2/3 times 8 minus 2 times 2, okay, minus 0. So we get 5 plus 16/3 minus 4. So we get the same thing that we got before. All right, so again, this is important because we didn't necessarily need to find the antiderivative. We could have used a calculator from here. Okay, we couldn't use a calculator for this part because our calculator won't put plus c and then plug in a value. So this is a very important differentiation there. So this is basically what I was explaining here. Whenever these are important, okay? Where you are at any given time is a function of where you started and where you've gone. So, say that you were walking from gym to my class, right? We could say you started at the gym and then you walked down the hall by the nurse's office and by guidance and you came to my room. All right? So that's exactly what it was. It wasn't like you started at the office. We didn't have to go back from, the front doors all the way to the gym. It's where you started, and then we add where you've gone. Same thing if you accumulate things like on your birthday, you start with 0 gifts or something plus what you accumulate, okay, as all the people get it. This is called net accumulation, and we're going to examine that in these last couple of examples. So that's the basic idea. Look at how important this is. So what you have now, or like our last example, f of 2, is where you started plus what you've accumulated since then. All right, so we'll look at some examples with this. F of 3, to find that, we have to see what we started with, f of 2, looks like we started there, plus what we would accumulate from 2 to 3 of f prime of x dx. Now, this isn't something we could easily take the antiderivative of, so we're going to just use our calculator. Here's the setup. All right, and I'm going to just put a little more detail in it because we know f of 2 is negative 2. And this, I'll just write the function f 4 times sine squared of 2x dx. Now you type it into your calculator. Okay, and I think this one is about 0.762 or 0.763, either way. All right, for part B, okay, f of 5 is just going to be f of 2 plus whatever we've accumulated from 2 to 5 of f prime of x dx. All right, so f of 5 equals negative 2 plus the accumulation from 2 to 5 of 4 sine squared of 2x dx. Type it into your calculator and you get f of 5 equals 4.038, I believe. All right, part C, this is something I'd like you to do in your whisk, and it shouldn't be too bad. All right, part D, basically what we're saying is f of x equals f of 2, right, plus 2 to whatever we're trying to go to, x, right, 4 times sine squared of 2x dx. And then the only other thing that I could do here would be replace that with negative 2. I'm not going to worry about that right now, though. All right, so calculator permitted. Doesn't always mean you're going to need it, but it's permitted. Let's see. If g prime of x equals this and g of 2 equals this, find g of 2. Well, that's not a tough question, right? G of 2 would just be negative pi. Wow, calculator's permitted and we didn't even need to use it. This one's going to be a little different. All right, g of pi is going to be g of 2 plus the accumulation from 2 to pi of g prime of x dx. Use your calculator, all right? And if you want, you could write it out so you know what you're typing in, or if you want to show, like anybody grading your paper, what you're doing, okay? E to the sine of x dx. G of pi is approximately negative 1.169. All right. And then the last one here, we have g of 0. It's going to be g of 2 plus the accumulation from 2 to 0. If we really wanted, and that's of g prime, we could switch this around from 0 to 2 if we make it negative, but we don't need to. All right, so that would be negative pi plus the accumulation from 2 to 0 of e to the sine of x dx. Type that into your calculator, and I believe you get something like negative 7.378. Not too bad, all right? And now, finally, to our last problem of this section. All right, at the start of Christmas break, it would be great if we could have been at this point at the fundamental theorem of calculus at the start of Christmas break, but we're not. All right, so a man weighed 180 pounds. So what that's saying is, and we're looking at a weight function, W of 0 is 180. So now, here's our function, okay, in pounds per day. That's the rate of his weight in pounds per day. What was the weight? So we're trying to find at the end of the break his weight. So this is going to be simple. Okay, W of 14 equals W of 0 plus whatever he has accumulated over those 14 days or 2 weeks. Okay, of W prime of t dt. So W of 14, and this I'd say you is a function where you could find the antiderivative, maybe. Maybe you can't, but if you can't, even if you can, actually if you can, write it down, and we'll talk about it in class. But if you can't, it's okay. Just use your calculator for right now. So we're trying to see the accumulation of this function. Type that into your calculator, and now if we get a number like negative 57, well, that wouldn't make any sense at all, that he weighs negative 57 pounds now. Okay, same thing if you got 10,000. Well, that wouldn't make sense for him to weigh 10,000. So make sure this makes sense. So his weight, I believe when you type it in, should be about this pounds. All right, and double check, make sure I'm doing that okay. Okay, so show your integral setup. You get points whenever you do a free response, and you just set it up. Even if you can't do anything else, you set it up. All right, and then we have our answer. So we are finally done this section. We're super excited, and we're ready to move on to the next one. Have a great